So now we need to find dy. So now for example number 6, they want us to find dy. And so let me just talk about this. It's called the differential dy. So if I have y is equal to x to the 5th plus 37x. This one's pretty easy. If I take the differential, if I differentiate this, normally what I would do is I would change this. I would say, I'm going to write all the formal notation down. d dx means I'm going to take the derivative of this whole equation, right? And so what I end up with is I end up with dy dx, right, on this side. And sometimes we'll call that y prime. These are two different notations that mean the same thing. Y prime, dy dx, sometimes we'll say f prime, but they all mean the same thing. Then I take the derivative. Well, this is 5x to the 4th, and then I would have the derivative of x with respect to x, which is like dx dx, and we don't have to write that down. And then this will be plus 37. Now the interesting thing about this, we haven't done this yet. Mr. Adams has been kind of prepping you for this. If I look at that and I treat dx like it's a variable, I can multiply both sides of the equation by dx. And so what I do is I distribute that through the parentheses, and my next line would be dy is equal to, in parentheses, 5x to the 4th plus 37 dx. And technically that's what we should do. The reason we want to talk about finding the differentials is that there will be a time where we'll have a rate of change for the y variable and a rate of change for the x variable. And in Calc 3 multivariate calculus, you'll have a rate of change for the z variable. Right? So you'll have a dy, you'll have a dx, you'll have a dz. And when you go, if you have a PhD in mathematics, and you do ecological models, you'll have 26 D something. So you'll have every letter of the alphabet, DA, DB, DC. Well, because you do. So that's one way to do it. Now that's a simple problem. Let's do one that's a little more challenging, okay? Let's do one that's just a little more challenging.
Wait, is that it? That's all you have to do?
That's all you have to do. And then you can evaluate it at 1. So it tells us to evaluate at 1. Well, so when we get to this point here, I'm going to plug in, I forgot to tell you this, they want us to evaluate this as x equals 1 and dx is equal to 0.01. Now what that means is we're interested in this parameter when x equals 1. That doesn't change. We know how to deal with that. But we have a rate of change for the x variable. Y represents something. X represents something. So it could be something as simple as water flowing out of a tank. You could have the height of the tank, which is changing as the water flows out. So in that case, you might have like a DH and a DF, one representing the change in height and the other representing the change in flow, if there is a change. Okay? Does that make a difference? Or the change in volume might be a better one. As the water comes down, the height lowers, so does the volume. So you might have dV, dH. And so you may be given that information. In fact, that's part of the challenge of the AP exam. They're going to give you rates of change. So we're going to take this same thing and plug it in and figure out what dy is. So dy then technically, is the rate of change for whatever the y variable represents, and dx is the rate of change for whatever the x variable represents. So in this particular case, we would say that dy is equal to 5 times whatever x was, which was 1, raised to the 4th plus 37. all of that times dx, which was 0.01. Like that. What does that represent? The change in y. Does that make sense? Okay. So now, if I crank through and I do all the math, I think you get 0.42. Probably should double check that on the calculator.
You do.
Do you? Okay. So you should get 0.42. Now that one's kind of easy. Let's do another one. Well, I'm waiting for my calculator to kind of load up. I'm going to skip ahead. I'm going to try to find one that's a little more challenging. So I'm going to skip ahead to numbers, or letter C. So I'm going to say C. One year when I was teaching, I had a kid, I would say letter number A, and he was like, I would say number A. And he would say, number, A is not a number. So now I always correct myself.
You must have been top in your class.
Alright, so now with this one, they want us to evaluate this, and they give us some information. They want us to evaluate this when x equals 2 and dx equals 0.05. Now, just to kind of help you, it doesn't say it in the textbook, but let's think of two things that might be related to one another. Where x is the independent variable and y is the dependent variable. Can you guys think of something?
What? Maybe like the height and distance of an airplane as it takes off?
Could be something like that, but I won't write it down on paper, but clearly x is something that changes. It's a measurement of something that can change. Y is a measurement of something that can change. And so this equation is the mathematical relationship between x and y, but x and y change too. So to find dy, or the change in y, because that's what they want us to find, we just differentiate. So I'm going to differentiate with respect to x, again, and I get 1 plus 1 dy dx is equal to, and now for this one I need to do the product rule. I'm going to say x times the derivative of y, which is 1 dy dx, plus y times the derivative of x, which is just dx dx. So this is an implicit differentiation. So what I'm going to do is I'm going to move some stuff around, and I get 1 minus x dy dx, and then y is equal to y minus 1. Did I do that right? I skipped a couple steps. That looks right, right?
Yeah.
Yeah? Okay. What are we solving for?
The dy
dx. So here's what I'm going to have to do is dy dx is equal to y minus 1 all over 1 minus x. But then I could just tack on the dx here because I moved it from there. So I get dy is equal to y minus 1 over 1 minus x times dx. Does that make sense?
Yeah.
Now this one's a little more challenging because, why? I don't have a value for y. So if I don't have a value for y, what will I do?
Plug and chug, plug in x and solve for it. Plug and chug, that's something.
So I'm going to have to solve for whatever y is. So I know what x is, I know what y is.
There you go.
Well,
Let's see what we could come up with. So if I rewrite this equation on the next page,
how do you say
x plus y is equal to x times y. And I'm going to evaluate this one. What was x supposed to be?
2.
2. So then I've got 2 plus y is equal to 2y. Hey, I could solve that. If I minus y from both sides, these cancel and I get 2 is equal to y. So y equals 2 as well. Okay? Does that make sense?
Mm-hmm.
All right, good. Let's go back. So now to find dy, what I need to do is dy is equal to 2 minus 1 all over 1 minus 2. What was dx? 0.05,
0.05.
right? So what do I got there? Let's do that on the calculator. I know what the answer is, but let's just do it on the calculator. Okay, so in parentheses, what was it?
2 minus 1.
2 minus 1 divided by, divided by 1 minus 2 times 0.05, and I get negative 0.05. Now what that means is x is measuring something, y is measuring something or representing something, y, when x is equal to 2. Its rate of change is 0.05. When x is equal to 2, because of the mathematical relationship, y is equal to 2. And then the change in y, at that particular point in time, that instant in time, the change in y is negative 0.05. Now really what that means is that y is decreasing 0.05, negative 0.05, right? That's where the decreasing comes from. While x is increasing. Does that make sense to you guys?
Mm-hmm.
Okay. That's pretty much it for that one.